basically which are being on the particularly on the experimental skills. So we can expect one question definitely in the advance, whether in the paper one or in the paper two, on the this experimental skills situation conditions, please. And the different experiments will be there concerned to the first year and the second year. So coming to the first year, different types of the experiments you can have, and one is regarding the surface tension, that is determination of the surface tension by the capillary rise method. Another one is going to be the Searle's apparatus, where you are going to determine the Young's double slit. So, and in the heat topic, specific heats and the apparent expansion. So there are certain the experiments in the first year. Coming to the second year, the most of the things are concerned to the optics. So coming to the optics, we'll be dealing with an experiments of the finding the focal length of the concave, convex mirrors and the lenses. Prism one, that is another experimental thing. So next one is going to be in our electricity, where we'll be dealing with an one of the most important thing is an there's a meter bridge which works on the principle of the Wheatstone bridge and the potentiometer. So these are the one important concepts on which these experimental questions are being regularly been asking on the Wheatstone bridge conditions. So please be careful of this particular one question you can expect guarantee from this particular experimental skills situation. So today we have divided this experimental questions based upon this experimental skills questions into the different models of the questions. There is an single choice, multiple answers, integer type, and we have just taken from the different sections, different models of the questions we have taken. So now in this one, we'll be discussing the type of the questions. First question here we'll be discussing is, so read the question carefully. Please don't be in a hurry in reading the question. Try to understand the question. A wire is there which is bent in the form of a right angle triangle. So with respect to the right angle triangle is bending. Okay, now so in front of the concave mirror he is placing whose focal length is ZF. Okay, which of the following four options which are qualitatively represents the shape of this particular image of the bent wire? Okay, so this is a bent wire. For whenever the person who is going to stand over here, for the person who is standing over here, and when he watches this particular thing, he'll not be able to see this particular inclination and all these things. With respect to the person who is watching from here, it seems to be this bent wire which is in the shape of a rectangle. He can able to observe only a straight line. This is the one. A line or a vertical line which is above the principal axis, which is having this is going to behave as some sort of an height of the object. So he'll be seeing the image of this particular straight line, which is vertical line above the principal axis. So the image of this one also be a vertical line on the other side. Or with respect to the mirror also, it will be only a straight line. This inclined plane doesn't have any impact. Okay, so now if we verify it carefully, let me name this particular point as a, and this is obviously at the focus, which is at the F. So that means the object distance from the pole to the first point will be nothing but an this F by 2. This will be considering it as an U. So from this one, we are considering the object value or object distance U as an F by 2, sir. And given that focus is equal to or the sum F, this is the one information given. Fine. So from this one, what will be your image distance? Where does the image will be falling? Your object is going to be within the focus or within the pole and the focus. So the type of the image will be an virtual, erect, and the magnified image will be forming. Okay. So then where it's going to be forming, let us examine that particular thing. I'm using the mirror formula. That is 1 by F is equal to 1 by V plus 1 by U. So from this one, we know the focus 1 by F, 1 by v value is the one we need to find it out. Plus, since it is on the object side, so I'm taking this as a u value as a minus f by 2. So this will be the 1 by f. If I bring it to the other side, so it will be the minus sign. This will be the plus sign over on this side, please. So this will be the 2 by f is equal to your 1 by v. Okay, so now we can get the value of the object where it's going to be forming. So the image is going to be from this one. You can get the value of the image distance, no problem for that one. So it's going to be falling at some other place. Now, if we observe this diagram carefully, how the image is going to be forming. So let me draw this principal axis here. And this is our concave mirror. So where the focus of the mirror is going to be here, we have placed an object. So which is at a distance of as given f by 2 from here. So this is your object O. Fine. So where the image of this one is going to be forming. So one of the image is going here is the focus. So the one which is going to be forming over here, or if I take that one, this is going to be the light ray which is going to be incidented on here, which will be definitely reflected back and it will be falling through the focus here. So incidents over here and it will be reflected back. Okay, another one, the light ray which is going to be falling straight at this particular point. So since the image, this is going to be the virtually, this is the run which is parallel to the principal axis. This has to pass through the focus. Then it's a real one. And an imaginary one will be like this, which is going to be here. So virtual erect like this. This is an erect image which is forming at this particular point. So let us the image. This is I and the J, and this is object O or image IG. Let me take it as an image IG, and object as OJ. So this is how it's going to be forming, and at this one, the rays which are being emerging are going to be these are rays which will be tending towards the infinity. So this is the type of the image that you are going to get it on that particular thing where these two are not going to meet each other. So this is one will be tending towards infinity. So this is how your image will be forming. Your object will be seen as a straight line. Image will also be a straight line here. So this is the situation. If we observe it carefully here, okay now. So he has mentioned that alpha will be what is that? It's going to be infinity. It's obviously it's going to be forming at the infinity. So better option is going to be the D here. Now, if you want to find out the shape of the image, he has asked in this one the shape of the image of the bent wire. It will be obviously a straight line, and if where it's going to be forming. So where it's going to be falling, that if you need to find it out. For example, if I take this particular distance, where this distance we know it is an f by 2. So for example, here some sort of an virtual or the image has been forming here. If I take this distance as an something x from here, then this will be the remaining distance is going to be the focus minus x1. So these are forming the similar triangles conditions. And we know that magnification formula m is equal to f by f minus u can be written as an height of the image by height of the object or something this one. So from this one, height of the image can be written as an which is minus f into this is f minus x by this is minus s plus x, or you can will be getting the height of the image to be equal to the focus. So this height will be equal to your f r del okay, and this distance he has given it as an f by 2. So obviously this is an extra thing that we are determining over there. The concern to the sun, this is not that much important. So what sort of an image you'll be getting? So this is the straight line where they tending towards the infinity. So this is the one very important over here. Now, next one. This experiment is concerned with an experiment to measure the speed of the sound by resonating air column apparatus. So tuning fork of frequency 500 Hz is being used. The length of the air column is varied by changing the level of the water in the resonance tube. Two successive resonances have been heard in the wave column at this particular thing. So there are the two successive resonances are being occurred. First, observe what do you mean by this resonant air column. So the resonant air column apparatus is a one which consists of a metal tube like this. Okay, a metal tube will be there like this, which is the actually one end is been open and other end is a closed pipe. So since one end is the open and other end is a closed side, it is called as a closed tube at that particular instant. Okay. So it's a closed pipe where you are going to get the node at the fixed end and open end you will be getting an anti. So we don't know which frequency and for which frequency this length is occurring and which frequency this length is occurring. So if I take general case for an second resonance, this might be the situation for you. Like this, the shape of the wave will be there inside them. Just bear with me. I'm just a very bad in this diagrammatical thing. Okay. So now here, this is the one. So two antinodes are been forming. This is another one. Two nodes are been forming here. Okay, so this is the case for an two resonances. This is the first location for the first resonance, lambda by 4 you'll be getting. This is your second length where the second up to this particular point. Where your second resonance is being occurred, that means second antinode is been forming at this particular place, which is been written as a 3 lambda by 4. The distance between the first node for this one, this antinode and yours this one is going to be the 3 lambda by 4 minus lambda by 4 is equal to lambda by 2. Lambda by 4 is called as your first resonating length and 3 lambda by 4 is called as a second resonating length. So in this one, since it's a closed tube, the frequencies will be in the ratio of 1 is to 3 is to 5 is to 7 is to 9 is to 11 like that. Okay, so generally what we do in the experiment is first you will be pouring the water such that only lambda by 4 is been occurred like this. Then you will be decreasing the level of the water such that 3 lambda by 4 is occurred. You will be further decreased the level of the water so that you can get the 5 lambda like that. So in this is the question. But the difference between any two antinodes, wherever you are getting the successive resonance, the difference between them is lambda by 2. This is the information we need right now. So here he has given the successive between any two successive lengths. The difference should be equal to the lambda by 2. That is a major important thing. In that sense, I'm taking it as n. L double dash minus L dash is equal to lambda by 2. So what is your higher value? It is 83.9 minus 50.7 is equal to lambda by 2. So now, so what will be the values are here? 9 minus, so this is 2 here. And point, this case, this is going to be the 3. 33.2 is equal to lambda by 2. So shall we get the lambda is equal to here, sir? So 66.4 centimeters. So this is the information. Let us see here. The wavelength of the sound wave, this is the one we have got. So first is C is the one we have got this information. So next one, sir. What is the next one? We need to find out the velocity of the sound, end correction, and the resonance 50.7 is corresponds to what? Now, as we have got this wavelength is going to be how much? So what will be the 3 lambda by 4, sir? Which is nothing but an 3 by 4 times of 66 point, what value we have got? 66.4. Yeah. 66.4 we have got. So now when you solve this one, basically, so how much you should be getting, sir, here? So this is going to be the 49.8 centimeters. That means your 50.7 or whatever maybe the value is there, 50.7. So that should be obviously close to your 3 lambda by 4. In that sense, your 50.7 should be representing your 3 lambda by 4, in the sense it should be in the third harmonic. It should be in the third harmonic, sir. So we have got the wavelength value we have got, and in the given question he has given it a frequency also there. So velocity of the sound can be obtained as a frequency into lambda. Frequency is 500 given in the question, and the lambda is going to be 66.4 centimeters into 10 to the power of minus 2. So this is the information. Okay, so on solving this one, obviously you should be getting some sort of a value. So 5 into this entire thing, this can be removed here. So 20, 0, 2, 32, 3. This is 332.0 meter per second. So obviously this should be your first option. Okay, so we have gone this one. Now, according to the wave motion, this is the concern to the superposition of the waves. This comes under the superposition of waves. Superposition of waves. In that superposition of the waves, it is a concept of the stationary waves. In the stationary wave, it is being dealt under the argon pipes. In the argon pipes, it comes under the closed argon pipe. Closed organ pipe. Okay. So resonance air column apparatus is a closed organ pipe. These are the general formulas till now we are using. So now he has also has the another one, please. So A and C we have confirmed. We need to verify. So in the D he has mentioned it as a 50.7 as a fundamental harmonic, but on solving we have got it as a third harmonic. Then that means your option D is going to be the wrong. We need to now verify your option B, which is an end correction. What do you mean by an anti-correction? Generally, when we measure the wavelengths or the lambda, we will consider that the end to end distance, only this distance as an lambda by 4, and with the scale also you'll be measuring this distance. But physically, actually speaking, due to the atmospheric pressure P naught, your wave, that is antinode, is exactly formed just above the this open end. This distance we are not going to measure, and this distance is called as your end correction. So this end correction is going to be E, represented by the E. It is 0.6 times of the R, where R is called as an radius of pipe. Okay, so total length, if I take that lambda by 4, if I want to take, then it will be the length plus end correction. We need to substitute like this. Okay, now coming to this R question, then that means end connection plus 50.7 should be actual value. How much you have got? This is 49.8. Theoretically, it should be 49.8. Practically, you have got 50.7. So this difference is due to the end correction value, and which is coming out to be the minus 0.9 centimeters. That means actually your antinode is been forming. Your antinode is been forming inside this one, please. Your antinode is forming inside this condition, so it is minus 1. Here it is been forming. So there is a difference of 0.9 centimeters here. Fine. So please be careful of this. So end correction is minus, but in the question he has given it as a plus. So this is going to be the wrong question. So this is the one, please, important one. So next one, one second, please. Live in class. So sorry. In plotting the stress versus strain curve, what is the stress versus strain curve? In this situation, the two particles for two particle materials P and Q, a student by mistake puts strain on the y-axis. Okay, strain he has taken on the y-axis and stress on the x-axis here. Fine, which of the following statements can be true? That's what he is asking, and this is also an multiple answers question. This is the one, please. So when you observe carefully, these type of the questions can be asked in the NEET also, please. So if you find out this one, this angle theta 1, if I consider this one, and the angle made by the P to the x-axis is going to be the theta 2, then clearly we can say that theta 2 is greater than theta 1, which implies that is tan of theta 2 is greater than tan of theta 1. Tan theta is nothing but the slope. Slope 2 is greater than slope 1. So what do you mean by the slope 2 is greater than slope 1? That means strain by stress of P is greater than strain by stress of Q. So that means from the given question, you can say that P is having the more tensile stress than the Q. Okay, no. So from this one, we can say that P is having the more, or that is the stress of the P is greater than the tensile stress of Q. So due to that reason, you can say that your first option is going to be the true. Now coming to the whether it is a ductile or brittle or anything. So since the stress is more, so ductile means the yielding will be more. Here you can see in the graph also the strain values of there is an abruptly ending value for the Q, but the strain values or as you are increasing, there is a strain is gradually increasing. That means the yielding region of the P is more. The yielding region, it has been elongating, it's been extending. So on that sense, you can say that is P is more ductile than the Q. Okay, now so since the P is more ductile, you cannot go for the brittle thing. Brittle is nothing but an immediately breaking like a glass. Coming to the Young's modulus of the P is more than the Young's modulus of the Q. So what is Young's modulus? Y is equal to the stress by strain. So in this case, 1 by y of the P is greater than 1 by y of the Q. What does it mean, sir? That means y or Young's modulus of the P will be less than Young's modulus of the Q. So this is a relation basically. So on that sense, this also the wrong option. So we can go for the A and B here, please. Now coming to our next question, please. A moving coil galvanometer has 50 turns and each turn has an area. He has given the area. So I'm just writing though it's a long question. Please, for these type of the questions, note down the given information. That will be the most useful thing. So even though the students think that they are grown up, but please put down all the values in front of you, whatever the given values, so that you'll not be confused and recheck the question for the given values. So area is going to be the 2 into 10 to the power of minus 4 meters square. The magnetic field produced by the magnet inside a galvanometer, that is V is equal to 0.02 Tesla, or I'll just put it into 10 to the power of minus 2 Tesla. Next value, what is the given? The torsional constant, it's an MCG, sir. The torsional constant, that is some called K, if I take it as an 10 to the power of minus 4 Newton meter per radian. When current flows through the galvanometer, the full scale deflection occurs in the coil, rotates by 0.2 radians. So that means for the full scale deflection, for full scale deflection, that means your IG is deflecting for an how much it has been rotated by angles, that is 0.2 radians it has been rotating. So that means the maximum rotational angle is 0.2 radians. Okay. So if you want, you can also convert that into the degrees also. That is pi radians is nothing but an 180 degrees. You can take the 0.2 radians is going to be how much? That is pi into 2 into 10 to the power of minus 1 by this will be the 180 in the sense. You can go for like this. This will be getting in terms of the degrees also you'll be getting. Okay, so that's not the thing here, please. So keep it aside. Now the resistance of the galvanometer, I'm taking the resistance of the galvanometer as a G, which is 50 ohm. There is a lot of information to be furnished. This galvanometer to be converted into an ammeter. So you want to convert, he wants to convert this galvanometer into an ammeter. How do you convert a galvanometer into an ammeter? By connecting an shunt across the shunt is nothing but a small resistance which is connected parallel to the galvanometer is called as an shunt. So in this one, total current will be flowing here. In this one, Ig. In this case, I minus Ig situation. Since both of them are parallel, you can write it as an Ig into G is equal to I minus Ig into S. So I'm just reminding everything now. Now coming back to the question. So now in what range you want to find out? You need to find out the I value is equal to 1 ampere. Up to this point you need to measure. So he's asking how much shunt, the shunt to be added to the parallel to the galvanometer. Value of the shunt he is asking now. This is what he is asking, sir. So to find out that particular thing, just we have written the formula Ig into G is equal to I minus Ig into S. I want to find the S value here. He's asked that one. G is a known, I is also known, but the problem here is Ig is being given in terms of the deflection. Ig is being given in terms of the deflection. We don't know that particular Ig value, sir. So how to find out that particular current? So torsional constant C theta is equal to, according to the moving coil galvanometer, this is NBIG into A. So substitute every value. What is the torsional constant given over there? Torsional constant, I have written it as in K here. This is your C. 10 to the power of minus 4. This is 10 to the power of minus 4 into theta. It's been rotating by an angle. How much, sir? Theta is equal to 0.2 radians. Number of turns coming out to be the 50 as far as remember. B value is 0.02. This we have written it as an 2 into 10 to the power of minus 2 and Ig I need to calculate for an area. What is an area, sir? I'm going back again. 2 into 10 to the power of minus 4. 2 into 10 to the power of minus 4. So just go ahead for the calculation on the either side, please. So this can be written as an 2 into 10 to the power of minus 5 in the sense is equal to, this is 15 to 2 is 100. So this one and this one we can remove here. This will be again 2 into 10 to the power of minus 4 into your IGs. Okay, so now calculate this by Ig, substitute here. So G value, he has provided it as a resistance as a 50 ohms, I suppose. I is how much you need to measure here, Ig value coming out to be how much, sir? 10 to the power of minus 1 in the sense it will be 0.1 ampere. Substitute 1 minus 0.1, sorry, into S. So S is equal to 0.1 into 50 by 0.9. Okay, so this should be your this one. So obviously it will be 5 by 5 by 0.9 we need to calculate. So now if I solve this one, it will be how much, sir? So 5 by 9 into 10 to the power 10. So keep aside this one. So this will be the 0.5. Again, 5 will be left over. 5, 5, like this it will be moving. So since we can go for up to this one, it will be the 5.55 ohms. This is your answer. So your this is going to be the 5.55 ohms. So this is how we can calculate. This is another very important concept. Conversion of the ammeter into the voltmeter. Conversion of the galvanometer into voltmeter. Conversion of the galvanometer into ammeters, or conversion of the voltmeters into ammeters. This is another very important experimental questions concept, please. So go through them. Okay. So if the measure in this question, it's a very lengthy, long question, I suppose. Okay. If the measurement errors is all the independent quantities are known, okay, then it is possible to determine the error of an independent of any dependent quantity. Okay. That means he is asking, he is telling that if we know the measurement of the errors of an independent quantities, in the sense, I would like to go in this particular fashion. This is your x1, this is your y-axis. Generally, along the x-axis, we will be taking the independent terms, and on the y-axis, we will be taking the dependent terms. So, if you know the x value, we can also find the y value. So that is okay, obvious thing. So this is done by the use of series is expansion and truncating the expansion at the first power of the error. So obviously is going for the binomial expansion, is not going for the higher orders of the power, because the errors are going to be the very small. Higher orders doesn't sense or doesn't make any sense in the addition or subtraction, so we can neglect that higher orders. So if the errors of the x, y, z are delta x, delta y, and delta z, then he has given certain relation to us. Fine. Okay, the series expansion of this one, this is exactly the binomial expansion. What I was talking, this is 1 plus or minus x whole to the power of minus n. For the x value should be very less than 1 case. This can be written as an 1 plus or minus, or this is going to be the minus n into x. These are your first two terms. Next two terms, obviously, they'll be changing plus or minus n square into x square, like that. So you can neglecting these terms. So we are only confining to the first two terms. That is the one he has taken. Then the relative errors of the independent variables, so that delta z can be written as an like this. Okay, fine. He has given in an experiment. The above derivation makes the assumption that, so as I have here mentioned, this is very less than one value. So based upon that one, he is dealing. In an experiment, the initial number of the radioactive nuclei are, so he is dealing with an radioactivity N naught is equal to 3000, sir, and it is found to be 1000 plus or minus 40 nuclei decayed in first 1 second. In the first 1 second, that is your delta N is equal to 40. This will be representing your n. This will be representing your delta n. N is nothing but your 1000. In a time span of, he has given it as a 1 second t. So I'm just taking down the initial values. This is your 1 second. So now ln of 1 plus x is equal to x up to the first power of the x. The error delta lambda in the determination of the decay constant lambda is, he's asking what is the delta lambda. So first thing we have to go for, we have to get the what is the delta lambda. So what is the relation between the number of nuclei and the lambda? So we, according to the basic definition, the rate of disintegration dn by dt is equal to negative of, because it is decreasing lambda into n. From this only we can get the information that n is equal to n naught into e to the power of minus lambda into t. This is the one most important. So now from this one we need to get the delta lambda. To get the delta lambda, I need to bring the lambda which is in the numerator, which is the power. I need to bring it on to the normal level. So for that one, I'm taking the logarithms on either side. So in that sense, this is ln of n is equal to, these two are multiplication factors. So that is ln of n naught natural n naught minus e to the power of log e to the power of sorry log of e to the power of a. Base e is also there. This will be simply equal to the a only. So that means I can write it as an lambda into t. So from this one, sir, this is anyway constant because n naught is a constant value, log of constant. So this is constant. Why I am going for the constant? Because I need the delta lambda for that one. We are going to differentiate. So if I differentiate this above expression, what is the differential with respect to the t? The differential value of the log of x is, that is 1 by x. So log n is going to be the 1 by n into, this is going to be the dn by dt. dt I'm going to write it on the other side. So this is equal to the constant, it will be 0. Or with respect to the lambda, let us derive this one is equal to minus of, this will be equal to the minus of delta lambda into t for a given time interval, or d lambda. Just deriving with respect to, differentiating with respect to the d lambda. So now rearranging this one for an small infinitesimal small elements, you will be expressing as an dn. For an considerable changes, you can write the dn as in delta n by n is equal to minus delta lambda into t. Now substitute all the values, delta lambda, delta n, how much value he has given? 40. We have written this one, time is 1 second. So this is 40 by, so what is an initial n naught values? So n naught are 3000, nr this is going to be 1000, and the number of nuclei decayed will be 2000 into. This is going to be the, what can I write here, sir? 2000, which is equal to the into time. Okay, na? So is equal to delta lambda into or minus delta lambda into t. What is the time taken there? It is of 1 second. So time t is equal to 1 second there, please. So now just substitute all the values. Then what can be the case here? So delta lambda will be equal to the, this will be goes off over here. This is 4 by 2 into 10 to the power of minus 2, or it is 0.02. This should be your delta lambda, where it is, yeah, it is hiding at the third place, right? C will be your option. Now coming to the next question, that is the question number 6, which is a matrix method basically. So in the multiple matrix also, in this one there is another model also. That means P can be matched with the multiple numbers in the list too. In another case, they can be matched with only one element. So this is one of the another interesting question where the combination of the lenses here is going to given. These two are the, both of them are the double concave lenses which are being joined, or it's a grouping of the lenses basically. So what is the basic formula for the focus of this one is 1 by f is equal to 1 by f1 plus 1 by f2 if there is no any gap between the lenses or the mirrors. If there is certain gap, then 1 by f is equal to 1 by f1 plus 1 by f2 minus d by f1 f2. This is the relation between the focuses or combined focal length or effective focal length if they are separated by some distance. Here, since there is no separation, you can directly go. Now, according to the question, all the curved surfaces radius of curvature is small r. So here it is been. Let us consider the. I am taking for the time being small r as a capital R, and the refractive index of the all the lenses is going to be the 1.5. So now we need to verify what is the value of the combined focal length of this combination here. So for what is your first one? First one is there nothing but an double concave 1 by f is equal to, how should I write, sir? This is going to be the mu minus 1. Both of them are the same. It is going to be the 2 by r plus this is also mu minus 1 into this is 2 by r. So now both of them are the same. 2 into this is mu minus 1 into 2 by r case, please. Okay. So now what can be the mu value is 1.5. So that is 2 into 1.5 minus 1 into this is going to be the 2 by r, 2 into 0.5. That is 2 into 1 by 2 into 2 by r. This will be the 2 by r, which is the combined focal length will be your r by 2. So where it is located, sir? So it is r by 2. That means P should be related to whom? Second one in the list 2. So P should be related to the second one means it should be in the option B and option D. So these two options are eliminated immediately. Now let's verify the second one. What is the second question is? Second one, these two are the plano convex lenses. So what is the plano convex lenses focus formula will be same. 1 by f2 and or 1 by f for the second one is equal to this will be the mu minus 1 into 1 by r plus mu minus 1 into 1 by r. So one plane side is going to be the infinity. Now add up them 2 into. Again, this is a mu minus 1 into 1 by r. This will be 2 into 1.5 minus 1 into 1 by r, which will be 1 by 2. So the your final answer will be the 1 by r. Here 0.5, 0.5 can be written as an 1 by 2. So that means your Q is being focused to 1 by r, where the 1 by r is there, sir. Is there any place that you have the 1 by r? Okay, sorry. Here the mistake, what I have the mistake? I have got 1 by f is equal to 1 by r. So f should be equal to the r. For this one, I need to search. So that means q is related to the fourth one, p is related to the second one. So P2, Q4 only you have got in the B. Option B, you can check it out like this. Or else if you want to determine all the values, we can also go. So these are nothing but two plano concave lenses. Third one, plano concave lenses is 1 by f is equal to, directly I am writing 2 times a minus sign, 2 into mu minus 1 into this will be the 1 by r. So obviously it is minus 2 into 1 by 2 into this is 1 by r, which will be the minus 1 by r, or f is equal to minus r. That means r is related to, so this one is related to the third one. So this is how, okay, no? Right, these are the things we have derived. And yes, S is nothing but a combination of the double convex and a plano concave. There are the two lenses here. So you can also solve, I go for here only. So that is 1 by f is equal to mu minus 1 by into 2 by r for the double convex. Next minus mu minus 1 into 1 by r. So 2 if I take it outside or if I calculate this one, this will be simply mu minus 1 into 1 by r. Okay. So mu value is how much, sir? 1.5 minus 1. That is 0.5. This will be the 1 by 2r, 1 by f. So f is equal to 2r. That means s value should be 2r. That means s should be indicated to the fourth. S is sorry, first one. Sorry. So this is our answer as we have done this one. Fine.